Let everyone get in the back here. All right, welcome everyone. Welcome to the Canadian Epigenetics and Environment Health Research Consortium workshop series. Today's workshop series is entitled Effective Science Illustrations by Martin Krzywinski. Delighted to have him here today, and delighted to have everyone here in the audience in the Vancouver hub. We also have hubs at McGill Genome Center, at the Dana-Farber Cancer Institute, University of Ottawa, and the McGill University Health Center. And we're also broadcasting remote. We have about 600 or so attendees for today's workshop. So before we begin, I would just like to acknowledge that UBC Vancouver is located on the traditional territory of the Musqueam people. The land it is situated on has always been a place of learning for the Musqueam, who, for millennia, have passed on their culture, history, and traditions from one generation to the next on this site. So before we start with the workshop, I thought I'd just give a little bit of an overview of the CEEHRC network for those of you who may not be aware of what it is. So the Canadian Epigenetics and Environment Research Consortium Network was founded in 2016. It's primarily funded through a network grant from the Canadian Institute of Health Research, and is also in British Columbia, funded generously through a grant from Genome British Columbia. And our aim really is, in a nutshell, to drive excellence in Canadian epigenetics research. CEEHRC represents Canada's contribution to the International Human Epigenome Consortium. If you're not familiar with CEEHRC, CEEHRC's mission is to generate reference epigenomes for every human cell type to provide a foundation to then translate epigenetic information into translation. And this just gives you an example of our latest effort, which is currently in preparation. We're hoping this will be released in this calendar year, which represents the latest collection of references, just under 3,000 human cell types. And this is from a consortium from around the world, and you can see the various countries that have participated. And I like to look at this. This is from this is a representation of reference epigenomes through a lens of something called the epi logo, which gives you, so each one of these rows is an individual tissue, and we have 2,500 of them listed there. So really pushing the envelope in terms of our ability to generate and understand references. CEEHRC has also developed standardized experimental and computational workflows for human epigenomic research, and is now moving into bringing in epigenomic analysis into precision oncology and in many other translational aspects. What are some of the networks of the CEEHRC network? So we host events like this. We also host an annual scientific meeting in the fall. And before I finish today's brief overview, I will tell you all about that. But we've hosted these both on the west and the east coast of Canada since 2015. We generate and facilitate access to epigenomics data through our main website, and we produce and curate a variety of different tools, software, jobs, training opportunities, and we also fund trainee travel awards. And to date, we funded 132 travel awards for trainees to attend international and national epigenetics meetings. Really at the heart of the network is really the trainee committee. These are images of all the fantastic people who are currently in our trainee committee. They really drive the knowledge translation in Canada. And this is just one example of a type of one aspect, which is a story that tries to overview a particular topic, which is then presented through our website. The main website link is shown there. This is epigenetics.ca. The trainee committee also hosts a podcast series. So this is Epigenetics, a CEEHRC podcast, both in English and French. And our latest edition will be Dr. Megan Jones, and her podcast will be released on Monday. That's the second in the second season, and our first season is listed there if you're interested. Again, both in French and English, and a fantastic way to really get the word out about the fantastic epigenetics research going on here in Canada. We also host a seminar series. This is the third Friday of every month. As many of you might know, these are supported by Active Motifs. This is very accessible via Zoom. It's 9 a.m. Pacific daylight savings time, and it is on the third Friday of every month. And our next seminar is September 20th, and we'll be having Professor Marco Mara, our very own Marco Mara from the Michael Smith Laboratories and BC Cancer, who will be presenting the next seminar. You can also watch the seminars. They're all recorded and available on our website. So I'm delighted to announce that our upcoming epigenetics annual meeting will be in Blue Mountain Resort. This is the first time we've been in Ontario. Typically we've been in either in Banff or in Esterel in Quebec. So we're visiting just outside of Toronto. It'll be the 1st and 4th of October. Registration is now open. You can see the link there, or you can Google it, or you can get there through our main website. Be delighted to see many of you there. So it is now my absolute pleasure to introduce our speaker today, Martin Krzywinski. Martin is a renowned scientist, he's looking puzzled, and data visualization expert known for his innovative contributions to the field of bioinformatics and genomics. With a background in molecular biology and computer science, Martin has made significant advancements in visualization of complex data, making scientific information more accessible and understandable. He is particularly recognized for CEEHRC, a software tool widely used for visualizing data in a circular layout, which has had a profound impact on genomic data representation. Martin's work, as you can see, extends beyond technical innovation. He is passionate about the intersection between science and art, often blending the two to create visually compelling and informative representations of scientific data. His contributions have not only advanced scientific research, but have also enhanced public understanding of the intricate scientific concepts. Martin continues to inspire the scientific community through his dedication to improving data visualization techniques and promoting the effective communication of scientific knowledge. And beyond all his professional accolades and accomplishment, Martin is simply a wonderful and thought-provoking human being, and being someone who, if you're lucky enough to meet in the hallway over morning coffee, you will strike up a conversation about nothing and everything, and before you know it, the day is gone. Welcome, Martin.
Thank you. Wow. Thanks for using my bird poster. Thank you. Thanks. Thank you so much. Just a minute. I'm praying to the Zoom gods. Yes? Yes? Works? Okay. Is the mic on? The mic is on. Yeah. Super. Thanks for coming. This is a workshop, but don't worry, I will be the one working. So I'm going to try to change the trajectory of your life to make you more sensitive to certain things about visual communication, and when you make your figures, what should you be thinking about? And I want to talk to you about what to draw as opposed to how to draw it. The how to draw part is really straightforward, or much more so than what to draw. And you can look it up on YouTube, Illustrator, whatever it is that you want to use. When you're communicating, you have to know what it is that your communication is about. And you have to only say that, I think, visually, at least, because there's often not a lot of room for other things. So if you look at something like this, some kind of a typical graphical abstract, you would be, you have to kind of assume you don't know what you're looking at. Remember that when people look at things, they don't actually interpret what is being shown as much as they are doing a lookup in their heads. I've seen this before. It was confused originally. Somebody explained to me what it meant. So now when I see it, I look this up in my head, and now I know what that's about, right? That kind of thing. You want to try to avoid those kinds of lookups. So you'd be excused to think that this is about the shape of the cell, but it isn't. It's about the extrusion of these channels to the membrane. But these channels are all over the place. It's about the channels, but there's little channels, little baby channels, and adult channels. And you'd be excused to think that they grow into adults. They don't. So why are the baby channels little? There's a lot of things that this figure does that just like, oh, well, of course I know channels are only come in one size. So how would we fix this? We would draw as plainly as possible. We have two states. We have some kind of a membrane. Something is going on at the top and something's going on at the bottom. We draw some channels. How many do we draw? Well, The message is that they get extruded to the membrane. So how about we draw 5 so that this doubles the number of channels in the membrane? Sounds fair. And there's one left over. This is really important. There's still some in the reserve. Okay, there's a cation coming in. I don't need to label cation everywhere else because once I've done that, you know what these pluses are. I don't have a legend because I can annotate nearby, and we'll see this theme come up again and again and again. Software loves legends, right? And legends, often what they do is they just make your quality of life poorer because you have to look somewhere else to figure out what the labels are. Just put them right there. And then we're kind of done. This is increased electrical activity. I wonder relative to what? Well, probably relative to the other state. So I don't need to say decreased and increased. I just need to say increased, right? And then if you're thinking, well, what about making the arrows pop a little bit more? The projector is kind of not representing this magenta as strongly as it could be. You could use a different color, and this is slightly bluer from this, right? But that's discretionary. So what is this about? It's pretty clear. Is there anything on this graphic that can be removed without impacting the message? No, nothing. Can stuff be added? Can the membrane be made into bilipids? Yes. Would that be helpful? No. None of it would be helpful. So you always want to step back and draw things as simply as possible. Always, always, always. You also want to speak plainly. Here's an example of a handout that speaks to some survey that was done in some school district about how students are unhappy. So if you were to read, say, a sentence on here that explains what this bar chart is, your brain would break a little bit because it says youth reported the number of adults they said they would feel comfortable going to if they had an important question affecting their life. ... That's really tedious, right? What are you saying exactly? Who wrote that? Why did they not edit it? So how would we fix this? Well, we would fix this in a number of steps because sometimes you don't know what the third step is until you do the first step. So we would simplify the questions. Am I alone? That's more powerful, right? You want to get to it. Do I have adults that I can trust? Okay. So what we do is we look at this. It's like, why are these dudes green? Why are these dudes blue? The unhappy ones are hollow, but the happy ones are hollow. What? Why is this orange? So this is green, blue, and orange because it's 1, 2, and 3. That's why we need a different color for each point we make. Otherwise, people will not know they're different points. No. So we're going to try to flip this around a little bit. We're going to make the unhappy guys magenta and the happy guys blue. But you can't see the black on top of the magenta faces, so we're going to make white outlines. Very nice. A little bit lighter. Now what I could do is the unhappy people who have no adults they can trust can be magenta in the bar chart. Okay, but now we have to think about, what is this about really? Well, how can it be fixed? It's pretty nice, but there is a subtle thing that we can flip around, and that is to put the unhappy people first. And that's because that's the point we want to make. This is the thing this is about. The rest we don't care about happy people. They're fine. Now what happens is you get magenta, magenta, and magenta come first in each data graphic. Very subtle thing. Do I need 100 students here to show you 60%? No. There's like 20 of them every 5%. It's fine. I don't need 100. So this is much simpler. It says the same thing, but the theme is much stronger. There's a strong color theme, which is the feel, and maps onto a feeling, which is what you want to try to get across. And everything else is just typography. So probably people have used BioRender. And ever since BioRender came about, you feel so accomplished because you can suddenly draw things you would never imagine being able to draw to great detail. But that's not helpful because you wind up torturing visual metaphors. Like, okay, I don't need to see a balance to understand that things are in balance. I need to draw for the mind. Your mind does not think in terms of fulcrums and balances and metaphors. It just thinks like, oh, this goes up, this goes down, or these two things are the same. So instead of saying something like this, where there is excitation in a star and inhibition is a cloud, and you went like, why is inhibition a cloud? There has to be a reason for everything that is drawn. And if you leave things to discretion, that's absolutely fine, but make sure that the choices you make speak to the underlying theme. And then, if you want to make art, you go and make art somewhere else. So how about something like this, where it's more of a table, really. Astrocytes release something, and in a normal case, it's balanced. Fair enough. So excitation and inhibition, I explained down here. There's lots of different ways of fixing graphics, by the way. This is not the right answer. It is an improvement, and there's many different kinds of improvements you can make. So if I were to wake up, tomorrow, it sounds a little weird. When I wake up tomorrow, if I were to see this graphic for the first time, I might fix it a slightly different way. But chances are I would remove the balance. I would always remove. There's no version of me that says, I love it. I love the metaphor. Right? And then in pre-symptomatic ALS, there's an increase of this. There's an increase of excitation. There's a decrease of inhibition. Now, importantly, what I've done is demonstrate the trends. It's very important. It's rarely done. You kind of draw stuff and you're hoping people will see the differences. They see the differences, but drawing the eye to those differences is a quality of life improvement for the reader. So when you look at a figure, the reason why it exists, ideally, not always possible, should be clear. Why does this figure exist? It's not a bad figure, except it exists in the vacuum. I don't know what I should be looking at. You're waiting for me to explain it. Now you feel like, oh, I have a little bit more information. It's about the second peak, something about the second peak, right? So try to build this in. Help people judge differences. So instead of just highlighting the peaks, I might draw a bar graph. I might think that, well, 50% is some magical cutoff. If it's above 50%, it's important. If it's below, it's not. So I will draw that cutoff, but I will not draw 10, 20, 30, 40. I will not have tick marks because I'm trying to tell you that it doesn't matter. 50% is important. Meet the standard of 50%. And then I'm going to think, you probably have some questions, like maybe the ratio of these bars, right? You want them answered, and why not just answer them for you, right on the figure? And that would be the thing I would show. It's pretty straightforward to parse. And then when I talk about the figure, if I were to talk about the figure in some kind of a scientific way, I would have everything laid out for me. And you would get it right away because of the very strong color theme. And it's basically a table. So this idea of a crispness, the terse language, some kind of a color theme is pretty important. Does this have a color theme? What is this about? Is the language crisp? Is this legend crisp? No crispness, no color theme. Is there a title that tells me what I should expect? The title says nothing. It just says implications. What are the implications? I don't know. I'm waiting for this figure to tell me something, and I'm like, why do I have to do all the work? So the idea is, the more friends you see during the pandemic, the worse it gets, and the cases rise. And so you kind of want the cases not to rise. And so you probably are thinking, how many friends can I see before cases rise? What is that number? Tell me, please. Just that's all I need to know. So really, it's about that. At some point, right, a long time ago, we could see friends. And if we saw too many, you'd get magenta. Magenta is bad, is the color of blood and disease and the apocalypse and so on. So use that as a bad outcome. Blue, happy, happy. Sky, good. But importantly, this legend also kind of acts like the figure, and you don't actually need the figure. The figure just tells you exponential growth. But the legend explains everything. So currently we are at 30%, and then outbreak is avoided. If I can see twice as many, I can see 60% of my friends. But if I see 80% of my friends, it's bad because it's magenta. So this is the line that is the hinge about which things turn. And so the figure could answer this, whatever, 62 plus or minus 5, whatever the number is, right? Here I filled in the magenta regime, all of these cases, everything here is bad, everything here is great. but it could be better in the sense that I could avoid the pandemic and see friends. Right? So why did that original figure? Of course, you know, the CDC put out daily briefings. Somebody was making figures 24 hours a day. Yes, it's a template thing. Yes, yes, of course, it's people are busy. But always think about what is the essence of the story and how do I tell it visually. It isn't that hard. You just have to often draw a lot less as opposed to drawing more. And there's a lot of visual explanation that can happen, but do not shy away from certain verbal explanations which get to the mind faster than a visual explanation. Because how do I say maximum tolerable visually? Pretty tedious. But if I just say maximum tolerable, you're like, that's fine. You don't need to draw that. So always think that do not draw what can be easily said. Draw what cannot be easily said. So are there rules? Should there be some rules that you must adhere to? No, but there are certain ideas and principles of how the eye organizes information that you should be aware of and break at your own peril. You will not be able to just undo this. Just know that if you're this person, you're not going to be achieving your goal quickly. You will achieve your goal. You'll just annoy people on the way there. And because people do not criticize figures, you will never know ever if people like it, ever. Nobody will criticize your figures because nobody makes good figures. Nobody, I mean like a large fraction of people, right? People will criticize your science. People will criticize your writing. Figures, they're like, I like it, but can you change it? That kind of thing. Okay, so there's this idea of salience, things that jump out at you, and you should map that to pertinence. The thing that's important is the thing that should jump out at you. Certain things jump out at you because you have a reptilian brain. Significant part of it is looking out for predators, and predators are, of course, red circles, and we see them right away. Great. So if you just want to make it exciting for the reader because nobody comes to your poster and you're wondering why, you're like, bring out the color. Suddenly, that predator, there's predators everywhere, and therefore there are predators nowhere. So now, how do I go back and highlight that red circle? Remember the happy faces with the black lines, but then when I made them white, the happy faces suddenly stood out? I just need to make that red circle different than all the other circles. And that white dot, the gestalt of this is it looks different, it'll be treated differently. Doesn't matter that there's all this color. That white dot punches through, and it's actually no ink. I've removed ink to highlight something. So this is an important idea, this idea of white outlines and no ink to highlight. All right. So this is also very important. Be very sensitive to the power of space. Space groups things really well, which means you do not need to commit a felony by doing this, or a misdemeanor, or a peccadillo, or a, oopsie. You could just do that. There's a very strong sense of row, 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 right? Because of the spacing. Spacing is your friend. At the beginning, you will be uncertain of yourself. Oh, is this enough space? No, I need to put in a line. I need to put in a box. I don't feel comfortable. It's going to spill out of the box. It won't. I've never this kind of thing can be very useful. We'll see how that can be applied. Tinting, light tinting is great. As soon as you start to put outlines, you're saying, I'm not sure. It's like repeating a word you say, and you just have to look, be sensitive to the space, and kind of recalibrate your judgment. And color can overcome some of that grouping. So this is why color should not be used for aesthetics, but color should be used for a theme, because you've got stuff to say. There's a lot of things to say in science. I mean, science is like, there's a lot of themes, there's a lot of ideas, and we're going to use up the color explaining important things, and we don't have any color left just to make it pretty. Do not think about pretty. Think about clear explanations. Okay, does this have good gestalt? Based on everything I said about gestalt, do you get a sense of a theme? Well, I very strongly get the sense that inside cells, things are pink. I've learned something already. And then what? I don't know what the patterns are. I feel overwhelmed. The legend is over. What is? It'll take me a long time. you get the feeling somebody shoved in all they knew about certain aspects of neuroscience into one slide. Can we fix it? Well, yes, but we have to take it apart before we fix it. What is really this about? This is about a bunch of different situations and a bunch of different cells where different things happen. So can we separate this out? Sure, we could draw some cells. This part doesn't matter that much. Just make it as simple as possible. This is where BioRender can fool you into thinking you're doing a good job by providing you a very detailed picture of some kind of a cell, very detailed drawing. You just need simple, no textures. And then we stack them, and then we set up this context. Here's an astrocyte, here's a microglia, whatever, and here are the things that we'll be talking about, and feed tight junctions, etc., and LoRa mixum, whatever, right? So here is the color. This sets up the theme. And then we have some opportunity to say something about cell membrane. Whatever, here's some aspect of the cell membrane. Now, the reason why I'm drawing this is because I'm then going to copy this over, but not in color, because I've already set up the color theme. I've already set up the stage. Now the stage is set, there's nothing on the stage, and the actors can kind of come on board. And then I can put in things that vary in these individual contexts. Things go up, things go down, whatever. It is complicated, but you scan across, and all the arrows are lined up. All the text is lined up to the extent possible. And then if certain things happen in males or females, or they're suspected to happen or they're unknown to happen, you can layer on color tinting to annotate. And then if you feel uncomfortable about the strong sense of rows here, you might add in some spacer lines. That would be fine, right? To kind of strongly imply a table. So, and then you have your disorders. This is what happens. Notice how these are blank because nothing is happening. The benefit of a table and empty cells is that it draws attention to where nothing is happening. Whereas in the original graphic, there was so much happening that you had no idea of when it wasn't happening. This is very, very important, this part of it. So this tinting is a very important way of saying inside or outside. It's very, very powerful. Very powerful. These are beautiful molecules. Hydrogen bonds. Great. But you get the feeling that the hydrogen bonds start to make rings. And these rings, although you understand they're not covalent rings, to the eye, they're polygons. So if I fill in the covalent rings, suddenly there's this very strong sense of something and something else, and then some interaction. Very strong. That filling in saves the day. So there's a box here. Is it important? Do you think that this box, if I were to remove this box, would all the text just fall out? No, it'll stay there. So what needs to be filled in? The dude. Why is the dude hollow? Why is he empty inside? I mean, some days we all feel like that, right? But, so why not that? Look how it breaks up the flow of information. It provides some eye relief, which is really nice. But you get this strong sense of inside and outside. And now I have this very strong sense of when the diaphragm, when the chest is moving, this goes up, this goes down, whatever, that I have this opportunity to draw this line. And you see where the line is inside and outside, because when the line is inside, it's on top of gray. And when the line is outside, it's on top of white. Over here, the line inside is on top of white, and the line outside is also on top of white. So of course you can kind of parse what you're seeing, and you know that the line is inside because it's below this other line, but it's not as a strong a message. So do you have a strong sense of the outside, the synaptic cleft? If you fill it in, it's much better. There's other things that have been improved, but the inside and outside here needs to be emphasized. And so you see what happens if I remove that fill, and that's often all you need to do. Now, there's no outline around that fill. Please do not fill it and then draw an outline around it. It's not necessary. The outline is the edge of the ink between the gray and the white is enough of an outline. You almost never need outlines. Yeah, you almost never need outlines, I would say. Sometimes that fill can be used in places where you feel like, oh, I wouldn't have thought of it. There's cycles here. So what is happening? Well, you know what's happening. It's a pathway. But let's think of the person who is making this graphic. Well, they're sitting down. They go like, methionine cycle. Put the label inside. Winning strategy. Folate cycle. Damn. I just shove it over here. So, see, now you're laughing because it's like, haha, I've done that before. Not anymore, though. The reason why that's outside isn't because it works for the design. It's because you made a decision somewhere back there 15 minutes ago that was bad, and you didn't know it was bad, and it's influenced your choices in the future. You got to back up. So the way we do it is we go, let's relax, let's step back, let's draw some axes, kind of often in our heads. Here I've drawn them to show you that everything is aggressively aligned. But at some point you can draw these in your mind. You do not need to draw them actually literally, grid lines or axes like this. But then you can highlight things like this and look at this strong idea of the folate cycle now becomes this kind of highlighted thing on the side, and then the two cycles are more entities as opposed to empty things around which it happens. You can this I think helps greatly with memorization or recall. This purine synthesis, folic acid, DHFR are uncomfortably close together, and then see DHF is like shove it in, and then there's this DHFR. It's like, where is this DHFR associated with? Things are too tight. There's not a clear separation of things because space is not carefully used. Whereas here, there is no chance that you're going to confuse purine syntheses with these labels because they're clearly very, very different. Okay, so for example, is there a good strong sense of inside and outside this graphic? Why is it horizontal? Why is there so much detail here? Why is there so much detail here? Why is there no detail here? Oh, that's probably because whatever clip art library there was nothing exciting for the Golgi body but the nucleus. Yes. So what we'll do is we'll flip it around, and then we'll have three places where we need to talk about things. And then we're going to draw as simply as possible. In other words, if I back up and I show you this, whatever, all sorts of exciting thermodynamic jitter is going on, this is not helping. First of all, you can't see what's going on, even if you're sitting here. Back there, you don't even know what's going on. You see light from the screen. So always think about the scale of things. Do not vary scale. Do not have microscopic text that is not legible, and then a reasonably sized text over here. You will only have one size text for a graphical abstract, let's say, maybe at most two. All right, so see, I have only two things here because that's all I need. Here's my little table. Here are the chains, and this is purely discretionary, right? Whatever, and the little Pac-Man, and then there's some text, and that's it. Now, if I do this, no. Have I improved the graphic? If you think yes, we need to keep talking until you go no. It has not added to the message at all. Nothing has changed. There's like a certain, no, it looks nicer. Does it? You need to recalibrate, I think, what nice looks like. This just gets in the way because you feel like this is an important step at the end of every design science communication process. You will have gone too far. There's probably a way to do this that's very gentle and very light and very invisible almost to the eye, but it's probably would not look like this. Right, so we're not going to go for pretty because that's not the job. The job is to always provide a good explanation. The explanation is the first thing. Is it well explained? Often there it is, just stop, get on to the next thing. So if you keep going, you run the risk of being unwholesome and nauseating, as Strunk would say. This is a great book, you should read it. It's about writing, but it translates wonderfully to drawing. If you want to make art, you can make cover art, and there you can just go crazy with data and things that are pretty, and this is very, very pretty. This is data. This is not figure one of a paper. It actually is, the clusters are actually a figure of a paper, but on a tree, it's not a figure. But then when you go and draw data, you do not do this. You do not, draw cancer. This is not the way to do this. So you try to remove all textures. You try to remove all gradients. You try to remove all unnecessary wiggles. Let's see if we can get into the minds of the person who drew this. All right, let's put the label inside. Sounds good. Star on top. Yep. Damn. Okay. The D won't fit. We got to keep the shape, though. That's the most important shape. That shape, that's a non-negotiable. Label outside, star inside. Okay, done. Fixed, right? So avoid that. It's completely unnecessary. If something is to be compared, it should be aligned. C and D share something in common, so there's a dot inside, whatever that may mean. And the colors mean whatever they may mean. They have to mean something. Otherwise, they should just be black boxes. The color has to have a meaning other than, oh, but that's just different. Because I know it's different. It's in a different part of the screen. All right. So I have a thing against drawing animals and being told where the needle was stuck in. This just means this mouse is well hydrated and gets medication of some kind, right? But look, what are you getting from this? Are you getting is it an anatomy lesson? Is it, what is the order of things? I blame a certain software package for this. So let's say when I draw a heart, all of these evoke different feelings, right? Sad, fine. Oh, first edition of whatever anatomy textbook and probably too much detail. But if I just say that, they're like, I get it. It's a heart. Yeah, it's fine. Let's get on with it. Do not draw things that you could just say. So now I can have a table: liver, kidney, lungs, heart, circulatory system. At no point are you like, lungs? What does that look like? You're not going to ever say that. This is not anatomy class. Now, in an anatomy class, I can't just say liver. I have to draw the liver. But now I have the experiment. I have whatever goes here, right? Genes, chemicals, whatever, hormones, and I fill in what is happening. This blank, the fact that LPS, lungs, nothing is going on, that stands out. Did that stand out at the top? No, there's no sense of patterns. Now I can really add more elements to this. I can highlight things, saying something's going on here. I can put the white dot. I can, red outline, whatever. There's more things to do. And this is a data table. This is a table. Do you need a graphic? No. Do you need to explain the patterns? And is it complicated? Do you need to draw attention to things that are going on? Yes. Very difficult to do that when you overdraw. So some people say, oh, the data speaks for itself. All right. Yeah? What does it say? How different countries have handled the second wave. Notice, that's not a question. That's an answer. How? What is the answer? How? I don't know. Here it is. Here. First of all, is the second wave this wave or that? What? Seems fine here. I don't know. What would we do? This is just raw data. There it is. Go ahead. We want to annotate it to the extent that we can. So let's say we're interested in the peak. Let's say we're in Canada, so we'll highlight Canada. And so we have this, second wave, peak location and full width half maximum, and then duration and center of Canada second wave, etc. Right? So you have this little annotation, and then I'm going to copy that over to the other countries, and now I can make the comparison. That's not bad. I could restructure this and place all of the locations of the widths and heights of peaks on a different plot, which will tell you the story from amazing, whatever you did there, 5, good job, to we need to have a conversation, right? Why is this number of cases so high? You have stories about individual countries. So now this is how, or the differences between the second wave, the length of the wave, and the height of the wave, if you will. And you have to know whether the audience will benefit from this or this. You just have to know your audience, and you have to figure out what is the story, what is the thing I cannot afford to not bring across clearly. And that's what you focus on. And then somebody will say, oh, I love the presentation, tell me more. And then you're like, well, I got a plot for you. And then you show them the raw data. People can always ask for more. They often cannot ask for less because they can't give your slides back to you. So the reason why we draw, right, is because it's hard to say, and you want to make it easy to compare. And you would be shocked that a lot of graphics make it very difficult to compare things. And you're like, no, yeah. Let's compare. Well, I don't even know what to compare. Well, after a while, you figure out, like, what's going on? I don't know. I still don't know why the mouse is nailed. I'm not sure that would actually happen the fact that this happened to me. Why is the mouse looking at its brain? I don't know. But then I discover, oh, there's drug doses here. Look at that. There's a drug doses. I can't, there's only 3 of them. Maybe there's 4. I can't tell. And I can't compare them because there's just too many numbers, even though there's not so many numbers. Has it been overdrawn? Cell viability goes up. Oh, now I get it. Now that I've seen the skull, I finally understood cell viability. No, that doesn't work this way. All of this can just go. Okay, so what we're going to do is we're going to treat this like data. We're going to have an axis because there's quantities involved, drug doses, right? So we'll have an axis, 2 drugs, 2 axes. So here's how it'll work. Very simple mouse icon. No eyes, makes it less personal. Dose A, dose B, you get it. And then the graphic extends beyond this, and then we drop our doses in. So it's clear that there's 4. There's no way you can miss it. If something is going on with this dose where something happens ahead of time, great. I can add in elements. I can add in more drugs, etc., etc. And then I just drop in what happens. Cell viability goes up. Great. Oxidative stress goes down. Great. And then if there's some kind of a pathway here or something like that, I could do that. But notice that through this judicious use of these inhibitory or inhibition arrow ends, I'm basically saying that inhibits this inhibits that, right? Everything is really nicely laid out. And you feel like I'm not going to miss anything. There's no way, unless you're just got like your couch is on fire and you've got something more important to worry about, you're not going to miss anything. Okay, then you can put in the channel, whatever, but you get the idea. This is really nice for posters. This is really nice for slides. And as you present, let's say, even though we're not really talking about presentation, I think that's how you would present. You would present by first introducing this idea of these 2 drugs. Then you would present the idea of there's the different dose regimes. Then these are our cocktails, and this is what happens, right? I've just used 6 slides or however many slides to build up a story, and I think that's better than just showing all of it all at once, even though it's really, really clear. Presentations are a really nice way to narrate. Okay, so we're going to align things aggressively. Pick your word that just takes no hostages, okay? What should we align? Is it aligned? Well, its stuff is in boxes, but what is this really about? I mean, you've seen these graphics. There's some number of people, and then some people decline participation or withdrawal. There's some number of biopsies, there's some steps, and certain things get excluded because of reasons. Would it be nice if those numbers were somehow lined up? Would it be nice if the reasons for the loss of a patient in a study, across a study, or samples was highlighted so that I could quickly see that? Basically, wouldn't it nice if it looked more like that? Where we had 91, then we lost 3, and then 88, we lost 1, and then we got submitted for sequencing. CDI just goes like, oh, great, done, okay. And then the red is bad because it's low tumor content, etc. That's all it needs to be. It doesn't need to be in different colored boxes because you just have a different set of tints, different row. That's it, right? Always try to align things that need to be compared. And there's always a way to do it, which may mean exploding the boxes and bringing the numbers out of the boxes and then relegating the text in the boxes somewhere else. Yeah, my remote died. So what we'll also need to do is encode intuitively. So, whoa. Okay. So is this a good encoding? What is this? What is this saying? Oh, is this going to be shown? Oh. Yeah. Okay. Thanks. This remote is magic until magic no longer works. I think there's like that's why we don't understand how it works. It's magic. Okay. So there's a couple of things that this graphic breaks. One is the confidence interval is encoded as two vertical lines as opposed to an interval, whereas the average is encoded as a bar, which is more of an interval. Okay, so we can fix that. However, the weirder mistake is if Alberta is a province and Quebec is a province, you see what I mean? Why is Canada here? Why is Canada, which is suspiciously looking like a national average, a data point? Yeah, one has questions. So if somebody is really making this quickly at the CBC, they shouldn't have made that mistake. So what we'll do is we'll put Canada at the top, and then we will put the provinces, and we'll encode things more intuitively. But this idea of highlighting the region of interest is very important, and so we'll just drop that as a quality of life thing. So you could quickly compare. So you could quickly see that Atlantic region falls well below, and Alberta is Canada's Spain, I guess. Notice how there are certain things that are very quickly said by this graphic to your eye that this graphic does not say. That strong sense of this yellow band and where things fit in. Even though you can get that information by just looking at that more carefully, it's tedious. I've moved all the averages or the numbers out and aligned them as opposed to at the end of the bar. I think that looks better, and I think it's easier to compare. And it's also something that you could just refer to on the side. It doesn't pollute the encoding. So there are some encodings that are familiar, but are they useful? We've seen these. So this can be fixed on a couple of levels. This can be fixed by just moving things around, right? I mean, okay, it's kind of frustrating because the 102, well, first of all, it's not clear that the 102 is unpacked into this at all, right? You would have to do the math. It just turns out this way. So can we slowly hint at that? Well, we can. We could do something like that. Now the legend makes it very clear that these three things are just unpacking the dark gray. Okay. But since the 102 is over here, why not just put the 102 circle closer to where it gets unpacked and put that first in the legend, because that's what we want to talk about. Very, very tiny little subtle changes in order make a huge difference. But then we're going to go, okay, it's time to admit Santa Claus isn't real, and whatever else you think from your childhood, and just like become an adult. Which means let go of Venn diagrams, which force you into shoving numbers in here that are very hard to compare, and use the upset encoding. So basically the intersections of sets are shown as a little matrix, and then the values inside the intersection are shown as a bar chart. It's very straightforward. It does not look very graphical. You don't get that feeling that you get by Venn diagrams, right? When presenters have a lot of text and a lot of text and a lot of text, and you're like, I'm waiting for some color. I'm waiting for a shape, stop text. And then they show you this Venn diagram, you're like, finally. Don't be that presenter, which means it's too much text, right? So this should not be used as eye relief. It should be as an explanation. But here I can reorder this. I can reorder the bar charts, and all that happens is that this matrix just gets resorted. I cannot reorder this. And sometimes the distribution is really important. Sometimes the idea that there's one big value and three little values and two medium-sized values can be very important. That's very hard to get at here. So order is important. And often order is something that the software that you're using may not provide you with, such as a R-facet plot. Wow, you figured out how you do it. It took you a couple hours, a little bit of tears, you're done. Thank God, it's over. Is it over though? Really? Why are they in this order? I don't know. The fits are pretty sketchy, but I'm not getting any message out of this. Is there a message? I think there might be. If you were to just say draw the profiles in a different order, you realize that there is this changing shape, and then these two are kind of weird. And then you'd throw in your data, however, right? Make sure that people understand that those are sketchy fits, and that would be what you would need to do. What is the order of, what is this? What's going on? There's some strategies that were used during the first wave, and there's some strategies anticipated to be used in the next 3 months. Okay. So of course, the most important strategy is other. No specific changes required. Okay, that would not be bad as a first option, right? But maybe we can have a more rational way to order all of these options and tighten up this text. This text is just all over the place. Okay, so we're going to fix this in a number of settings. First, we'll just tighten up the way that the text is wrapped. So we'll wrap text on noun phrase boundaries or in ways that makes it easier to read. So for a given regimen, comma, feels like a natural line break. Substitute IV drug with, feels like a natural line break. Oral cancer drug. Okay, so then the legend will look just like a plot. So far, no other changes have been made. The legend was just brought in. Then we'll flip it around so that the first wave is gray because it's the comparator, it's the baseline. And then the next 3 months is the thing we're comparing the first three. I could never really understand why they put the next 3 months as the first thing. So the idea is we go from gray to blue. And where I've reordered things based on the change in use. So this strategy will have the most change in use, which is no specific change required. And this strategy will have the least change in use, which is defer routine imaging. We used to do a lot of deferring. We're not going to be doing that anymore because we learned a lesson, and other is whatever. The other is the other thing. But this side is the value added. It explains to you why I'm showing you this. It says 3 strategies we're going to do more of, and everything else we're going to do less of. Now, it really depends on how this is worded, right? Because defer routine imaging is really not doing something. So I would argue that that language needs to be changed as well, because it's like some strategies are described as doing something, and some strategies are not doing something, but that is up to the creator of the graphic. Very straightforward, not much needed to have changed. You just need to support the information on a relatively complicated graphic with a smaller plot. So there are places where you show 2 different things, much like our channels, state A, state B, and things are different, but in some cases, things are different in an elaborate way. And it's hard to see where the differences are. Created with BioRender, I knew it. First of all, why aren't these side by side? It would be just like a lot opportunity lost, right? There's some explanation about what's going on. There's some explanation of what's going on. Why is this pink? There's a lot of colors. What are the colors? What's important here? Well, it seems to be about pH, so it seems to be about acid and base. So we get our 2 colors. We have acid and alkaline gray, but do we need the full spectrum? What if we just go with acid magenta and base blue, and then we don't need the green, right? Because you get green bacteria. But then if you read off the spectrum, it's like, does that mean that this bacteria, what? Okay, so what we'll do is we'll step back and we'll just draw something pretty straightforward and gray. Then we'll fill in, this inside-outside is really important, as it was done originally. Then we'll draw our bacteria, gray. because it's just background stuff. There's stuff in there. And there's other stuff that we care about, the blue guys. Oh. So we have decreased pH, and then we have increased pH. And there's more blue stuff. These are lined up. So you're already getting a feeling of something, and then there's lots of room to tell the story. See, I could tell the story there's no text yet, but you can maybe figure it out. These useless guys make some of these magenta things. So the projector is kind of making it dark. But anyway, right? Magenta, decreased pH. And then this guy, you do something with it that's blue, and it makes him a blue guy. That's these guys. And then these blue guys make the blue dots. And then the blue dots, I guess they do something magical to the magenta, and they kind of... Right? So now you know. And you kind of already knew because of the flow of information. And the only thing that needs to be, well, fixed, it doesn't need to be fixed, but it is something that irks me in my redesign, is that I always try to go left to right because that's a more natural way of reading things. Whereas I needed for this to go right to left. Now, that's not a big deal. I'm not asking you to do too much. You are capable of looking right to left, I know. But wouldn't it be great if there was some other way of doing it so that everything flowed really nice? But anyway, right? And that's all you need to do. Now, finally, I can put in the mouse, etc. Probability, blah, blah, blah. That is a really nice place to place the mouse. And then if you say, but listen, gradients never? Gradients sometimes. Here's where I would be okay with a gradient. Not super happy, because this could just be a magenta tint and a blue tint. But this idea that right, this is a crypt, this is some kind of a valley, and there's more concentration. You see what I mean? Like it's okay. It's okay. It's not crap, and it hasn't ruined the rest of the story. And here is the narration: patients with inflammatory bowel disease. Here's the intro, and here is the kind of conclusion. And so, right, no inside outside. Pretty good inside outside, and then this idea of the color theme. It's very clear that this is about going from magenta to blue. So one of the things that doesn't get done as often as I think it should be is this idea of putting labels closer to where they belong, because software is generated so that it makes legends. And it puts legends in a box. Everything is in a box. So the plot is in a box, the legend is in a box, the whole thing is in a box. And a lot of times the boxes are not necessary, but where I want to fix this is to break the labels out of the legend and closer to the plots. This is not always going to be possible. But when it is possible, it's very powerful, particularly for posters. It means you can break out from the figure 1 legend, figure 2 legend, text, 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 and bring the text into the figure, bring the legend into the figure. So that's already better. We've labeled things here. I've just moved things off to the side, but you could sometimes get away with labeling plots. What is this color scheme? The color scheme should reflect the experiment. So here, for example, FSK, we have these two cases, DMSO, we have these two cases, and then there is a difference between them, and here is a description of the difference. Right? And now, what I could tell you is I could tell you the value at the last day value, and I can color code that, and I can color code the difference in some kind of, and explain to you what the units are, and then I can explain to you something over here. Gray text meaning don't worry about reading it right away, probably some kind of detail that needs to be filled in. But this is very, very useful, right? Because it makes those comparisons explicit right on the page. And so before you even know what this graphic is about, you know what needs to be compared. And by knowing what needs to be compared, you can better understand the setup of the experiment. You can better set up, well, what are the conditions? What are things that are worth noting? And then the color scheme becomes purely based on the function, as opposed to any kind of, oh, I like green. So this kind of annotation can be very helpful when it comes to posters. This is a very reasonable looking poster. It's pretty nice, but you can maybe think of some things that I would want to remove, right? It's a 3-letter word, box. But there is opportunity lost at this poster. First of all, okay, it's fine. It's orange highlight for the meaning. We'll keep that. But then we have let's look at these people. 55% female, 45% male. Do I need to draw these people? Is this for aliens who cannot distinguish? Right? No, I don't need to. Already I'm thinking my red flags are up. This orange in the pie chart, okay, Moderna. This Moderna is orange, but if I look over here, oh no, orange is Delta hospitalizations. So the same color from one panel to the next suddenly became something else. Why are these colored? That's because it's a pie chart. And we know pie charts are bad, so we're going to fix that. And it would be nice if we just very quickly were told where we should look. For example, is this good? I guess it's good, but how do I know it's good? Is it if it's above 80? If it's above 90, it's good? So we'll do something here. We'll keep the orange. I'm going to try to stay with the theme of the poster, the visual theme of the poster, because it wasn't bad. So orange, study period, right? We've set up our criteria and our categories are where the graphics go. Okay, this is so far so good. Then we're going to draw in the data. So we have participant characteristics, female, male, age, vaccines received, 2 doses, I'm going to give you the percentage here. So in fact, the bar chart is not that important, but it's fine. 2 doses of any vaccine are protective, so there's hospitalizations, all Delta. So now magenta basically is something that is bad. Anytime you see magenta, it's like, oh, this is bad. That's just a color that I think is useful to indicate non-optimal outcomes. So there's hospitalization. So really, there's only 2 colors here. The orange is the highlight, or the garnish, and then magenta is the data. But now, right, it's kind of like, how am I supposed to understand these panels? The data are there. Now go ahead, enjoy the conclusions that kind of naturally form in your head. What we do is maybe highlight where we need to be looking. So for example, this is very good, this is less good, this is good, this is good, and now explain what these are. So here's 90%. Hospitalization risk in vaccinated people reduced by more than 90%. I'm drawing your attention to this number because it's important. I'm drawing your attention to this number because it's important. I'm explaining, for example, here there's some fake Latin here to basically show you that you can annotate. You could say something about the cohort's age. You could say something about whatever. And there's lots of room for this kind of annotation. And if you remove the data, then the annotations stay in place. This is not done often enough in posters. In journals, you're not going to be able to do that. They won't really let you bring copy into the figures. But for posters, it is very, very, very useful. So we have until 12:30, so I might have a couple of other examples. I wasn't sure how quickly I was talking today. So are there resources? Of course there are resources, lots of resources, but I think that you're better off reading a couple of classic books and reading them several times, or going to the same place. So I have a poster kind of hospital where I fix posters online, and you can look through these designs. Here's a template, which is a poster about making posters. It kind of, talks about how to format things, how to bring in annotations into the figures. See, these figures have their plots, but there's lots of text here, which gets shoved in or placed gently. So, and in explaining what you're seeing, there's these trends that are appearing, and they're highlighted. And so you're always trying to draw attention to some trend line, some line here that is differentiating these distributions. There's some trend line here and so on. Graphical abstracts as well. there's a hospital for that, where they get fixed. And here's a graphical abstract about graphical abstracts. And maybe one of the things that I want to focus on is arrows. Do not distort arrows, use plain arrows with an equilateral triangle head, manage the arrow weight well. And that's something that you just need to not let software bully you into using some kind of fancy schmancy arrows. Arrows are really important because, and again, I didn't spend very much time on them, they can mean different things. They can mean look here. Sometimes arrows are for that. It's like look here, and now look here, and now look here. And it becomes a very like a police state graphic, right? Or something moves and it goes from here to here. Now there's movement. So that could be an arrow. And sometimes it could be like it's a crop. It's like this is also that, but it's now drawn at a different scale. So keep in mind that when you draw arrows and they all have these different meanings, that flow of information can be muddled because you have one visual element playing different roles. A lot of things is about typography, an ancient art. Lots is known about it. This is an excellent book written by a Canadian poet who says in his sections, like letters have a life and dignity of their own, which makes you feel like you need to protect them. And there's a style beyond style, which makes you wonder, what is that? Can I get there one day? There is a style. I don't know what it is, but it's nice to imagine that maybe we can enjoy it. Tufte's book is excellent. His first book, you just need to read one. He has a bunch. Really the philosophy of drawing, which is use ink on data and do not use ink on garnish. And then if you have time and you want to think about thinking and how to think about classically and romantically about something, I recommend this, which has more to do with philosophy than motorcycles, although motorcycles are kind of the metaphor. It is a classic. So let's go through a couple of more examples, which is something like this table. These are discretionary things at the end. So here's a table. You quickly get the sense of what's going. Does this table help you in any way? It just looks like, I can't read this. Like, I don't know what's going on. I don't know what's going on. Are these colors appropriate? Can I see what's inside that red box? No. So we're going to first remove the outside box. So far, so good? Yeah, that's pretty good. Huh? That's better. What am I going to do next? Remove the little boxes. What? Suddenly, it feels like somebody opened a window or something, right? Yeah, I know that feeling. Okay, but it's still crap, but it's crap, but it's such an easy fix, which goes to show that when you say, I don't have time to make good figures, that's because you spend all the time drawing boxes. I could free up all this time. It takes less time to make a good figure than to make a bad figure, because bad figures are generally bad because they're overdrawn. Right, okay. So then we would think about all the colorblind people out there, and I'm sure that there are many in the audience, and we would think about the text. So I don't like vertical text because I don't like to move my neck, okay, for somebody else. If somebody says, hey, move your neck, and you're like, no, get out, no, I'm going to move my neck when I want to. Maybe never, or maybe right now, right? So we're going to try to do this table in such a way that the text is legible. So already you're getting a feeling what it's about. Here's like, I don't know what it's about. I have to read this. Oh, it's about bias. Oh, okay. So we'll have bias. There's 5 different kinds of bias: random sequence generation, allocation, concealment, whatever. These are selection bias, performance bias, or other bias. So here are the authors, here's the dates of publication. So now you realize, oh, it's about publications and whether they have certain kinds of biases. Okay. So now we can look at the color scheme for colorblind people, because we're going to need to put something in the table, and realize that red and green are not great choices because you can't tell the difference. So we'll maybe pick some other color palette. Color is a whole topic on its own. I didn't really get into color selection and all that, but when in doubt, you go to Color Brewer. Color Brewer is a tool. Brewer palettes were created by Cynthia Brewer, who was a cartographer. She still is a cartographer, I guess. She manually selected them to have certain properties that are beneficial for data visualization. One of them is that they have this property called perceptual uniformity, meaning that the perceived differences between adjacent color seem to stay the same as opposed to big jumps in adjacent colors. So we'll pick this pink, yellow, green because this is colorblind safe. So we'll go back to our table and we'll start to fill in where there is bias and where there isn't bias. Now at this point, it's a little ambiguous. Is green mean good, meaning no bias, and magenta bad, or is magenta no what? Right? Not clear. But it is colorblind safe. So we can encode bias, no bias in a couple of different ways. So bias present, yes, possibly, no. Okay, that would be like the first attempt. That's not horrible, but it's not as good as it could be. Because possibly it could be like a small version of yes, as opposed to a different color, a different tone, just like little yes, you know, no, little gray, yeah, possibly. And now you start to think, are you thinking what I'm thinking? Why not just no is blank? There's no bias, just leave it out. That's not done enough, right? So yes, this can look like missing data. Bias was not assessed for that publication. And if that was the case, then we would need a no. But since everything is basically no, and the color and the figure legend would explain that, you know, basically no is empty, this is not bad. But now we could do more with this. We could start to annotate the table by, say, how many biases and possible biases there are per publication, and count down and add up the columns of how many publications have a certain kind of bias. This is very helpful. This starts to now let you speak about the table a little bit more quickly, saying, let's draw attention to the publications with the most biases, as opposed to coloring every fourth row or fifth row to try to break up the table in a meaningful way. Maybe even reorder them. I haven't even talked about the order. The order is alphabetical. Is that really important? How would you use this table? I don't think alphabetical is good here, because it isn't like, oh yeah, O'Dwyer, that guy. Let's find out where he is, right? Of course, I knew it. So it isn't that you need to look up O'Dwyer. Wouldn't it be nice if you was basically just want to look up the publications with the most bias, perhaps, or the least, and see how that distribution looks like. So maybe now you're even thinking, what about drawing a bar chart of these numbers, right? To kind of continue to annotate this, which I didn't do, but that's absolutely possible. Even these kinds of, this line is a nice little touch because it continues along this line. And so basically this is like a small version of the plot or the table, much like the dose graphic early on with the mouse, where the legend is built into the plot and incorporated into the plot without being a thing on the side, you know, in a box. Okay, I'll wrap up with this example. Thank you for coming. I hope I've made you sensitive to certain ideas, and let's take questions if there are any. Thank you.
Martin, I think we can start with there's one question on the Q&A from a remote attendee, from Dinakar. Great chart. What tools do you use to make these charts?
Illustrator. Very one-word answer, but it doesn't have to be that. It could be some other tool, as long as you have the ability to put things into layers, which is something that PowerPoint does not let you do. PowerPoint is not a graphic making thing. It's just a template for slides. So it is inappropriate to use PowerPoint because it does not make certain things easy. It does not make tinting easy. It does not make alignment easy. Everything is more difficult and more tedious and takes more time than it needs to. Not that you cannot make this in PowerPoint. Yes, you can. You just don't have all the tools at your disposal. And by tools, I mean alignment and organizing things into layers. So, for example, in that annotation poster where I showed you the annotations, but I removed all the other elements, and that's because they were in different layers, and I could toggle the visibility of different layers to see whether a layer and its information stood on its own. That's very important, is that everything in the graphic should stand on its own. It should not use other elements as a crutch, ideally. Sometimes that's not possible. So I would recommend something like Illustrator, and then just get used to using it. It'll take you several months, however long it takes to get better at something. But once you're good at it, you will be able to tackle all of these problems. You'll be able to make figures for publications. If somebody says, I need a figure that's 1.5 columns, 174 millimeters wide, exported at 600 dpi, you won't be like, I don't know what that means. I'm just going to pretend that it didn't get said. Whereas with PowerPoint or Keynote or whatever, essentially that's impossible. This idea of having an artboard of a specific size that will then be printed at that specific size, where elements are placed on the page at a specific size. So that's also very helpful.
We can take some questions from the room.
Yeah.
Okay, we have one here, and then we'll go back to.
Sure.
Thank you for your presentation. I was wondering what's the golden ratio for presentation, like a poster, the text and graphics?
Oh, you mean the ideal ratio? Or do you mean the golden ratio is, have you people seen lots of art, Da Vinci's art? It's about 1.62. Geometrically, we respond well to that proportion for reasons, maybe because of whatever, arm, leg. There is no such ratio. There is no answer that says you must min-max this quantity. You must tell your story well, you must explain well, which might be that if you have a poster which is qualitative research, you may have only text. And if you have a lot of data, you may have a lot of plots. You're going to need to support those plots with some words, ideally. You could fight really hard and have no words on your poster and just use graphical elements to show cutoffs and now look here, now look here. That will be a great challenge. So what does your story need? What does a good explanation look like? Do I need to see clusters? Do I need the clusters labeled? Do I need to be explained what the method is, and so on? So generally what is appropriate is the use of space and organization. I need a strong sense of I need to look here. This gives me the broad outline. This says what is the problem and what did I observe on a poster. So try to maybe bring that up to the top as opposed to leaving the conclusions down, rotting somewhere in the basement. And then as you go down the poster, you start to support what you said with information. And you start to unpack some of those words. So do not, and so speaking to this question, if you get a template for someone, just be aware that that template may not be appropriate to what it is that you're trying to do. It can help you because it just like cut and paste into this box. That can create that samey posters from a given lab. So everybody at a conference goes, oh, the poster with the 3 dogs at the top on every poster, that's from this such and such a lab, right? So there could be some need to brand yourself, but that should never come at the cost of a poor explanation. The branding should be very light, and you'd be surprised how tiny little things stand out when you're not shouting. Well, but when the template is shouting at you, then nothing really stands out. So sometimes the template needs to be used and then thrown out and reframed. And a lot of posters are about what is the flow of information? Do I have a lot of plots that maybe benefit from stacking because they share an axis? Maybe they do. Like I have an example here. Let's look at one about cannabis, because for some reason there's a lot of drugs. There's flies, knees, surgery. Do I have it here? Oh yeah, okay. Here's a poster about cannabis. Here's a bunch of plots. I mean, it's a typical poster. Text, table, plots. So if you look more carefully at the plots, they're really about fraction of people that did certain things, or that something could be said about them in the way that they use cannabis, what they use, how often, etc., etc. So you realize that you could hide the meeting controls, anyway, whatever. You could stack those plots because they share an axis, which is the fraction of people that do this. And so now that could look like that. And if you go to the final poster, let's just skip past this. Okay, skip. Sorry, skip there. If you go to the final poster, you see that all the plots are stacked up because they share the participants fraction axis. And here's a table. And so now what happens is that the poster is about something cannabis, something. Here is the study. Here's some periods where there's some assessments, there's some study aims, etc. And now the data come. And the table is pretty long and tedious. And so what we're going to do is we're going to say make some statements about employment or language or whatever that is worth discussing. And here's where the business is, so to speak. The key observations are kind of brought into next to the plots. As opposed to in the original version, see, there's this discussion is kind of like, well, I guess you're saying what I should have observed, but I'm not going to remember what I observed. So I'm going to look at this, and a third of the pregnant women stopped using cannabis in the first trimester. I don't know where that is, right, in the data. So this is where a template, and you can kind of, I think, maybe feel that this template is from, it's a university template because they use, they have a green branding, so that everything is green, which is fine. It's fine. Cannabis is green, so maybe this university is like perfectly branded for this kind of work. But it is not. This does not help the story. This does not help compare the data. So there's no perfect. There's only A and B testing, worse and better. There's another question from online.
Yeah, we can do online. We can alternate. Sure. So maybe this is a quick technical one from Amelia. Is there a way to ensure OR saves your PDFs in nice layers that are openable in Illustrator?
Yeah, an Illustrator file and a PDF file is basically the same thing. If you create an Illustrator and save as a PDF and load it up into Illustrator, you'll have all your layers. Yep.
Do we have something here?
Yes. Yes. You could just yell.
It's for the people online. Stay with here. Thank you. I was wondering if you could comment, if you look at publications that came out 5 years ago, 10 years ago, do you see different trends emerging with how people are, are certain illustrative elements fashionable?
Yeah, I was kind of hoping to stop talking about biorender, but I guess I can't.
How important do you think it is to stay up on those?
Yeah, there are. If you go back to the 1400s, right, you can see the trends are, there's certain things that were very difficult to draw. And so people didn't draw them. People didn't draw gradients. People didn't draw elaborate things. They just draw as simply as possible, perhaps too simply. Everything was in black and white. And then color and then certain software packages made certain things possible. So for example, if R shows up and ggplot shows up and there's a default theme, a lot of plots will just have that default theme. At some point, I think the color settings in Excel were such that if you saw a plot, and it's like, yeah, that was the Excel default color theme. So the default color theme is a really powerful trendsetter. And things like biorender are also powerful because they provide more options to people, and then people feel like they need to use those options as opposed to use them only when those options are really the right answer. So when it comes to trends, there's a lot of data figures. There's a lot more multimodal data collection. There's a lot of really complicated stacked plots, oncoprint type, gene mutations, lots of cohort information. But where the trend is not improving is in the technical implementation of those figures. There tends to be poor consistency across a paper in how things are formatted, in the size of, say, text or line weight in figures. There are some people who are very serious about doing their figures, and you look at a paper and everything looks very much like it was done by the same person on the same afternoon. And it makes reading the paper really clear because they set up a visual vocabulary and they're in control of everything. You get the sense that they're in control. And still in many papers, you get the sense that it's a cut and paste thing, where Prism made one plot, R made another plot, some other software made some other plot, and it's just cut and paste onto the panels, and they get shoved. and then that's that. And I would like to see more of that consistency, because it generally means removing a lot of things and removing a lot of the idiosyncrasies of all of these default settings. But there's a lot more clip art now than there used to be. And in different fields, like the people love drawing the mice and the syringe, wherever it needs to be poked. And that's something that's hard to get out of because it's like I feel comfortable. It's my security blanket. I need to show them that they won't know that it's done on a mouse. What if they think it's done on a hippopotamus? So, right, there's lots of ways to say all those things, but stepping back from the graphical and then putting the data back in, that needs to be always on the forefront of your mind and everybody's mind, is that it's really about data and about the fundamental concepts, and it's not about the garnish.
Awesome, thank you.
So I'll give you a question from an anonymous attendee.
Anonymous?
Yeah.
Might be controversial.
It's not very controversial. Well, maybe you think it is. You said pie charts are bad. Any situation where they are appropriate to use?
Yeah, they're really appropriate to use in talks like this that shows you that they're bad. The reason why these pie charts are bad, they're kind of like Venn diagrams. They hijack you into placing numbers into the slice, and you cannot draw a trend line on a pie chart. Now, you could say that pie charts are not meant to have trend lines drawn on them, such as this pie chart. Really, what it's supposed to be is about 81, 10, 10, and 11. But I would say you could do this with a bar chart. And one of the reasons why this pie chart isn't very good is because it now changes the encoding for really just some proportions. Everything else is a bar chart except this. So they can be, I've seen them used to good effect. I saw this a long time ago. It's a matrix of pie charts. It was like 20 by 30, huge table, and each pie chart was essentially just one quantity, and then how much ink there was in each cell reflected the size of that quantity. So think like circle size. Basically, it was that. It was instead of the size of a circle that reflected the quantity, it was more like the completion of the circle. But people can't even cannot agree on how to draw a pie chart. Should we put the slices in order? Some people say put the biggest slice counterclockwise, the next biggest slice clockwise, and then fill in the rest. So it's all of those kinds of things. I think that they make text layout hard, because if you want to label all the slices, you're quite limited to how to do it. You can't do it like in a bar chart. You have to maybe put them in a legend, but that means that the legend is just another thing to draw. So I'm not a big fan of pie charts. I don't think they improve anything. I think what they do is they add a splash of color. And if you want to add a splash of color, you can. You could add a splash of color to a bar chart. You can add a splash of color to some kind of a theme. But in the end, somebody who wants a splash of color might benefit from a better explanation and say, wow, I thought I came in wanting a splash of color, but I left with a great explanation, and now my mind has changed. And anytime I see a splash of color, I'm now suspicious that I'm not going to get my explanation. That's not necessarily a legitimate conclusion to draw about everything, but it's not impossible. Any other questions? Yeah.
Would you suggest stacking the discussion and the results section together, for instance, if we're doing a poster?
I'm sorry, stacking the discussion?
And the results section together, just in case we're doing like a poster, because to save space.
Yeah, I think at the beginning, you make one poster, you make one talk where there is the objectives, aims, discussion, conclusion, methods. There's that standard menu layout. So it becomes very clear in your mind where things go. And then you dispense with that, and then you tell the story that is appropriate for the amount of time that you have, which is, this is what we saw. Let's talk about it. So it's basically, the whole thing is a discussion. This idea of a discussion is a very artificial boundary, right, for certain statements to be made. It's like, now that you've seen the data, let's reflect on it. But if the data were 25 slides ago, you're not going to remember the data. So oftentimes a discussion is much more appropriate tucked in right next to the data. This is the discussion. Basically, key observations and discussion at the same time. Why would I want to separate them out? This is what I observe when I go out into the world. This is what I think this means, and more talking about what it implies for future things. So I think with a poster, you have this opportunity, bring things together that are meant to go together.
I think we've unfortunately run out of time, so we don't have time to answer all the questions, but I hope you can join me in thanking Martin for an absolutely fantastic
Thank you.
presentation.